My talk is called Flex Your Synapses, Mindfulness and the Brain. And I have two main goals that I would like to try to accomplish tonight. The first is that some of you probably walked into the room pretty skeptical of mindfulness meditation. You've probably heard about it because it's getting pretty popular. But you might be worried that it's another media type fad, like the Atkins diet that everybody's really excited about, and then it's going to fizzle out in a year or two. So for that part of the audience, I'm hoping to provide some evidence that supports that this is a valid way to try to change how we think and experience emotions. For the rest of you that might be a little excited about mindfulness and wanting to check it out yourself, I want to give you some data that will help you have realistic expectations about the benefits of the practice, because especially with the popular media getting a hold of this practice, it's getting a little distorted on what it can and cannot do for human thinking and emotional experience. But before I get into the mindfulness, I want to first talk about what's our current state of the brain in society today. And there's kind of two major trends that we see when we look at what are people's brains doing when they're not actively engaged in a task. And one of the things that we do really well is we are mind wandering, or we're distracting ourselves away from the present moment. And a research project that came out of Harvard looked at this by giving undergraduate students an app on their phone that would ping them randomly throughout the day, and it would ask them the question, what are you thinking about? They had several options, things like I'm daydreaming, I'm planning, I'm worrying, and one of the options was I'm thinking about what I'm doing. And they found that about once every 30 seconds, these students were thinking about things other than what they were currently doing, or they are basically mind wandering or thinking about stuff that was off task. Now that's not necessarily a negative thing. There's certainly a place for mind wandering. It does serve some purposes. But it does seem to be something that's becoming more pervasive in society, because we have a lot of great technology these days, but it's kind of designed to up the level of our mind wandering. The other thing they found that our brain states are doing is dwelling in negative mood. So that same study, the question that followed up, what are you thinking about right now, was how do you feel? And they found that when students reported not thinking about what they were doing, they also reported having a larger negative mood state than if they were actually thinking about what they're doing. And that might seem counterintuitive, because some of the options were I'm daydreaming, I'm fantasizing, which is usually pretty positive content. But what we've learned is that when we're fantasizing and we come back to reality and we check in, when we do that comparison of fantasy land to here where I am, that actually induces negative mood state, because it's rarely as good as the fantasy was. Other evidence for the increase in negative mood states that we're dwelling in is that there is an alarming rate of teenage anxiety and depression, and now we're even looking at childhood anxiety and depression diagnoses. And over a fourth of the U.S. adult population will be diagnosed with an anxiety or depressive disorder during the course of their lives. And these are just the people that actually get to a clinic and get diagnosed. So we know that the incidence rates are much larger than this for people who never seek out help. And then if we include people who deal with subclinical levels of anxiety and depression that still impact their day-to-day activities, like being stressed at school, we pretty much get the entire population looking at negative mood states. Now again, there's a place for negative mood states, and it can be useful information. But what we found is that when we're practicing these things on such a regular basis in our day-to-day activities, we're basically creating strong neural networks that represent this information. And this is facilitated through a neural process called long-term potentiation. So our neurons, in some ways, can be thought of like muscles, and that when you exercise them, they grow stronger connections between each other, just like muscle fibers get stronger and harder to break. The first time that neurons communicate information, they have a synapse that doesn't have a lot of connection points. A synapse is the gap of communication between neurons. So the bottom left of this is showing you a synapse between neurons that haven't communicated much together. And then the more times they communicate, they grow these extra points of communication until they form a really strong, lasting neural network. And that's the long-term potentiation. That's what you can see in the bottom right here, is these neurons have now fired in a pattern successively a couple times, and we have this extra physical stuff that grows in that synapse that supports the representation of that information. So right now, the suggestion is that the neural network for mind wandering or being distracted and the neural network for having a negative mood are really strong and automatic in our brains. So it's kind of what we default to when we don't have a task that directs us to do something else. So this is where mindfulness meditation can come in and address those two different states. So a quick definition of mindfulness meditation. The first principle of it is a present moment awareness. And this is where one of the first misconceptions of what the practice is can get communicated by popular media. So there are some meditation practices where the goal is to zone out or have kind of this other plane of conscious experience. And mindfulness meditation is the exact opposite of that. It is actually an attention training where you're learning how to bring the focus of your attention into what am I doing right now, into the present moment. So in this practice, we often use sensory cues from the body as things to pay attention to, because if you're getting a signal from your body, that's part of your present moment right now. The other principle is adopting an attitude of non-judgment and acceptance. And this helps combat those strong, automatic, negative neural networks. Now, our brain is hardwired to try to predict what's going to happen in any situation, and that can be adaptive sometimes as well. But what that means is that we carry around a lot of expectations of how we think people should act, how we think different events should play out, and when those expectations get violated, that also generates negative mood and creates biases in us on how we expect other people to be behaving. So this is simply letting go of all that prior experience that usually influences how we're acting and behaving, and trying to just have an experience as if it was the first time we were having it, and see if we get a genuine value of the experience without these outcome expectations. So there's a rich history of mindfulness meditation in Eastern traditions. A lot of people list Buddhism as the root of this practice. It came to Western culture in 1979 when John Kabat-Zinn created the mindfulness-based stress reduction therapy at UMass Med, where he still is affiliated. And he basically stripped out the social and cultural components of this practice, developed a very standardized 8-week therapy treatment that he started using with his patient group, which were individuals suffering from chronic pain disorders. And that now has been picked up and it's widely used in clinical psychology, and it's been found to reduce the symptoms of those chronic pain disorders, eating disorders, substance abuse disorders, anxiety disorders, mood and depressive disorders, attention deficit hyperactivity disorder, and I think the list will continue to go on and on as more research is conducted in this area. And this is where mindfulness meditation also stands out from other training techniques that are getting popular, like luminosity or the brain age game, where those games, while they do increase your ability on them, you get better at the game, there's no generalizability of those skill gains. So they don't apply to real life stuff. Where mindfulness seems to be a skill training where you're honing your attentional skills, and it does apply to a lot of other stuff. And I'll show you some more data about that. So there's been several decades of rich literature from clinical psychology that supports this as a valid way to treat a lot of psychological disorders. But where my field kind of has kicked in has been from 2000 on. So this is a result of Google Scholar searches for mindfulness meditation and neuroscience from 1979, from when John Kabat-Zinn started the practice, to now. And you can see it's just an exponential increase in the amount of research that's being done in this area. And this research I was completely unaware of until I came here my first year as a faculty member. I was trained in mindfulness meditation when I was a postdoc at the University of Illinois. And it was for my own personal reasons. I was really stressed out. My advisor was the instructor for the MBSR class for clinical PhD students. She said, "Why don't you sit in? It seems like you could use this." So I did, and I needed it. And it had a profound effect on me, so I stuck with the class. I became a group leader the following semester, and then my instructor went on sabbatical, and I ran the class in her absence. And so I came here with a strong personal practice, and it was something that really impacted me. But that first Christmas here, that same advisor asked me to help her with a literature review. And she specifically said, "Will you review the neuroscience literature on mindfulness meditation?" And that was the first time I really delved into this literature. And what I found blew my mind and convinced me that this was something that was worthwhile and I needed to incorporate into my teaching as well as my research. So I've been doing that ever since. And so what I found when I looked into this literature is that we all have this frontal parietal attention network. It's a very strong, heavily connected network between our frontal lobe, which is right behind our forehead, and our parietal lobes, which are just above our ears. And this network is responsible for our ability to control our attention, or do what we call executive functioning, which is our ability to stay focused on a task, ignore distracting stuff when it comes up, flexibly switch the strategy we're using to try to solve the task if the context changed, notice when we've made errors, a lot of really kind of sophisticated, nuanced cognitive processing. And so another common misconception of mindfulness meditation is that it's a relaxation technique. And if that were true, we would see these neurological changes happening in networks other than the frontal parietal attention network. We would see more amygdala effects, more ventral medial, prefrontal cortex. These are things that are involved in our fear response and our stress responses. But study after study after study, and I can keep doing that, will show that when people practice mindfulness meditation, the gray matter density in the areas of the frontal parietal attention network increases. So what that means is that those neurons are creating more and more connections. That's what makes gray matter in the brain. And they're creating lasting, strong neural representations of our ability to control our attention. So this literature is great. It astounded me to see that this was where it was having its effect because it's directly related to my research. But this only tells us that there's size differences between people who practice mindfulness meditation versus those who don't. So the question is, do these size differences matriculate into some kind of behavioral change that we can see in these people? So there's a lot of research out there on that. It's a very active area of study right now, but I want to show you a pretty solid piece of research that came out last year. It's a meta-analysis of K through 12 mindfulness programs. There's 24 different programs in here where students either did a mindfulness-based intervention in their schools or they did not. So there's a control group comparison. And what they found was that the largest area of impact on these students was cognitive performance. And they found this through a variety of tests. They used attention tests, creativity tests, and they just looked at their actual class grades and found increased grades in the students who did the mindfulness intervention. So again, suggesting that the strongest impact of mindfulness is on these cognitive attentional processes. After that, they did find significant reduction in stress in these students. And then also they found increase in resilience, our coping mechanisms, for when those students encounter negative events. Okay, but those seem to be secondary to this cognitive change that happens. So here's where my lab comes in, because we can see this behaviorally, but we still don't know what's the mechanism. What's driving this behavioral change? We can make inferences from the structural changes we saw in the brain. But what my lab does is it uses a technique called electroencephalography, or you might have heard it as EEG more commonly. So this is me with one of the many fabulous research assistants I get to work with in my lab. And what I'm doing is we've put a bunch of electrical sensors on his scalp. And these scalps are able to detect the electrical output of the brain, which is the results of neurons communicating with each other. And so when enough neurons fire at once, we get these fluctuations in these electrical signal of the brain, and it can tell us very refined information about the different stages of information processing a person is going through. So this data is from a collaboration with Maureen Hall in STEM Education and Teacher Development. And what we've been doing is we've been doing these lab measurements at the start and at the end of the semester. And we have 3 groups of students. These are all students in the Teacher Licensure Program. One class has been doing the 8-week mindfulness training that I learned when I was at Illinois. Another class is our active control. So we developed a deep reading intervention that's also 8 weeks long. And that controls for a little bit of daily practice for 8 weeks, and also convening as a group once a week to discuss that experience with the practice. And then of course we have a control class that hasn't been doing any sort of training. The lab-based task we use is called the color word flanker task. And in this task, you get presented with 3 words that are stacked in a vertical manner. And your objective is to tell me what color the center word is printed in, and ignore the colors of the words that appear above and below the center word. So in this case, you would respond green. And what we manipulate is how we present those words. So an easy trial is a congruent trial, when the flanking words and the center word are all the same color, like you can see on the bottom 2 squares there. So those facilitate your ability to respond. And then we have the incongruent trials, which are the 2 top ones, where the flanking words are a different color from the center word. And what we find is that interferes with your ability to respond. There seems to be an extra cognitive step that we have to go through, where we have to actively inhibit that distracting information and refocus on that center word. And then, of course, you can tell we've also manipulated the emotional content of the words. So we do this with both neutral and negative words. So in one task, we can look at the ability to control your attention and the ability to control your emotional reactions. All right, so in the EEG data, we do this technique where every time we show them those words, we average the signal from the brain together. And what we get from that is called an event-related potential, which is a response that's specific to some sort of stimulus. And what we found in our data, now these are freshly squeezed p-values, so this is likely to develop as I get to analyze the data more. We've cranked them out in the last 2 weeks. But this component, the P100, is the earliest neural index of attentional processing. So it's very basic attention, just simply how quickly can you notice that there's something visual in front of you. Okay, so it's highlighted there in the box. It happens about 100 milliseconds after you see a stimulus. And it's a positive going deflection. That's why it gets the P, although that's completely irrelevant. What we found was an interaction between our groups, the time being the before they did the training versus after, and the congruency versus if they were all the same color or if they were different colors. And so this graph shows the interaction, and it's actually quite simple to break down. The blue bars are showing you the P100 before they did the training, the red bars are after. And what this is showing you is the difference in that component when you compare the incongruent trials to the congruent trials. So it's reflecting the interference effect. How interfering were those incongruent trials? And what you can see is that if you focus on the last 2 bars, that's the only significant comparison there, that the people who did the mindfulness training had a smaller P100 response after the training. Okay, so there's less of a signal after they've gone through this training. What that suggests is that the mindfulness has strengthened the neural networks for attention. They're basically more efficient at processing those visual stimuli because their behavioral responses do not differ from the other groups. So they're using less neural energy to complete the exact same tasks that people are using more neural energy to do. Now in this task, that didn't matriculate into a behavioral difference, but these are things that happen within 400 milliseconds in my lab. So conceptually, when these people go out and do more day-to-day activities, they basically have an extra cognitive reserve because they haven't burned through as many resources just to engage their attention onto the stuff that's around them, in theory. That's something that needs to be studied still. Also, the connection between this component and mind wandering has never been established because nobody's ever looked at it before. So that's another area of research that we can pursue. The other finding we had in this study is we had everybody fill out surveys of different mood states. And what we found was with this survey that measures trait worry, which is considered kind of the cognitive side of anxiety. It's when you're in your head and you have this verbalization to yourself going back and forth. It takes up all your working memory sources and it distracts your attention away from the present moment. What you can see is a dramatic decrease in trait worry in our individuals who did the mindfulness training versus the deep reading or our control group. So what this suggests is that obviously mindfulness reduces worry. What I'm hoping with some more sophisticated analyses is that I'll be able to show that improved attention is the mechanism that drives the reduction in anxiety. So why I think that might be true is because if you can improve your ability to control your attention, that means that you can direct your attention away from the distracting, worrisome thoughts and towards other material, where usually that's kind of an automatic thing that's out of our control, that the worry just takes our attention and steals us away from the present moment. But it doesn't rule out the possibility that we actually have just changed the perception of the individuals so that their worries are still there, but they've kind of changed their relationship with them, that they don't impact them as much as they did before they did the training. And there is some literature on mindfulness research that suggests that that is also a mechanism of change, where you can affect more the psychology end before you start impacting the cognitive and neural side of things. All right, so in this brief talk, I've shown you that there's a lot of data that populations diagnosed with physical and psychological disorders can benefit from this practice. School-aged children seem to show benefits. Normal, healthy adults seem to benefit. UMass Dartmouth students benefit. I've told you I've benefited. So, ergo, there's a good chance that you could benefit from this practice if you were willing to give it a try. Now, how much is always the question I get after that. And I can't tell you how much. We don't know. That's another very active area of research right now. The original structural data that showed size changes in the brain, they looked at people who have been practicing for their lifetimes versus people who never had. Okay, so obviously there's some problems with that kind of research because it could be something about people that made them go to the practice that caused that brain change, not the practice itself. But more recent research has done the standard 8-week training and shown structural brain changes across those 8 weeks. The functional data is definitely supporting that 8 weeks is enough. And now I think there's enough research out there for me to say with a moderate level of confidence that 2 to 10 minutes a day for 8 or more weeks does enact lasting structural and functional change in the brain. And that good old meta-analysis from the K through 12 programs actually made a nice graph for us that looks at minutes doing mindfulness for their semester and the effect size of those benefits I went over in that meta-analysis. And so in the bottom left, those are programs where they went in once a week with children and did 35 to 45 minutes a week. More towards the top right, where you're getting the stronger effect sizes, they incorporated home practice, so the students were doing between 1 to 2 hours a week. Okay, so there's your wishy-washy answer to how much. All right, so I am nearly out of time, but the real thing about mindfulness meditation, I think, is that it's an embodied experience. I could stand up here and try to scientifically explain the practice to you for a long time, and you might never understand what it is I'm trying to talk about unless you try it. So I'd like to invite you to give it a shot with me. We'll just do it for a brief couple minutes. But for those of you who want to try, why don't you try sitting up nice and straight in your chair. Simply sitting differently already tells the brain to pay a little bit more attention as you have brought your mind into this room. And then if you're comfortable with it, I invite you to close your eyes. If not, you can kind of have a loose gaze in front of you. You're not really focused on anything. You can look at the back of the seat in front of you. And we know from other research in psychology that if I told you to try to suppress your thoughts, that thought would just get more distracting. So instead, I'm going to invite you to start thinking differently about your relationship with your thoughts. So we typically tend to walk with our thoughts hand in hand down the road. We give a lot of truth to our thoughts as if they are reflections of reality. But I invite you to consider that thoughts are just a byproduct of the fact that you have brains. Neurons need to fire about once per second in order to stay alive, so it's like breathing for them. And the byproduct of neurons firing is thought. So it's not something you can turn off, but it's also not something you really need to pay attention to. It's just always going to be there. So now imagine as you're walking with your thoughts, you're going to let go with your hand. And those thoughts can keep on marching down the road, but you're going to turn the corner, and you're going to go a different direction. And maybe you can realize that who you are and where your attention is separate from your thoughts. Now that we've unhooked our attention from thoughts, let's bring it down into the body. You can imagine it like a spotlight that shines from your forehead. And let's try directing that spotlight onto our breath. There's no need to change how you're breathing. We're simply observing the sensation that the breath provides. So we know if that is the focus of our attention, that our attention's in this present moment. You're feeling a little weird, maybe a little self-conscious. And adopt the mindset of a curious scientist that observes the breath as if it's the first time you've ever drawn a breath. Letting each breath be an opportunity to begin again, to Gently guide your attention out of your head and back into the body. Ready, go ahead and open your eyes.